Good day. My name is Brian R. Smith, and I'm going for my mobile gaming masters at Sail University. And I'm going to take you through some unit testing that I'm doing in Unity and is using their test runner service. So with that, let me share my screen. Yeah, the whole desktop here. Grand. Okay, so I'm going to do a little bit of just kind of the environment here. So for Unity, I've created a separate folder here called tests, and this is where I'm putting my test scripts in here. But to allow these test scripts to have access to the real scripts, these are the ones that are running my game, you have to create an assembly document here, and I've got that selected. And in there, then you say, these are the scripts that are, the different things that I'm going to allow. And this is another assembly that is over here in this scripts folder. And so it's assembly called scripts. And what I was having all sorts of problems with is that when I created this scripts assembly in here, it was breaking all the references to a lot of my game objects, like my photon networking and my other packages that I had loaded and installed, breaking the references to them. The compiler was all doing all sorts of bad things. And I found the trick. And the thing is, online, everybody always shows you, oh, here's my brand new project, and it's pretty and it doesn't do anything. And I'm not making, it's not complex. And of course, all tutorials should be that way. And the problem is I was jumping right into the middle of a project. And so I had a lot of these other things loaded into Unity, and you needed to basically over here, you can see the assembly definition references. You need to include them to be able to add them to the assembly. And I noticed as I was adding other things to kind of trying to make this to work, that I noticed these were the options here. So as I started to include them, then my compiler errors were going away. So a little bit of wisdom there, as my grandma Keller used to always say, live and learn, die and forget it all. So it's definitely a learning lesson right there. So this is the environment that I'm using that I've configured for my testing. So here's the test runner. So here are all the test cases that I've created, and let's just run them and see what happens. Oh, hey, we got a lot of code bugs out there. So let's start fixing them. Let's start going through them and taking a look at this one here. We got a routine called test runner. We're expecting 10 and we retrieved 11. So let's take a look at that. So we'll hop back into the code. So as I was learning this environment, the first thing I did was just create just a real simple static method in my big main movelerp1 C#, which is where almost all the logic for my WWI Flying Circus exists right now. So I just created this for test running, for this test runner unit testing, and basically you just pass it an integer. It increments the integer, and if that integer is greater than some kind of maximum, then it sets it to the maximum, and then it returns that counter back to the user. But what happens if you just accidentally reversed this logic, checked for maximum, and then incremented it afterwards? Well, let's take a look at that in terms of testing. So this is the test runner, and basically I created this, and it does a few things. Like here, it just plays with creating any kind of game object, and then asserts that this game object was actually created. The other thing here is it just does this basically waits one frame and using a coroutine. So just some things to kind of make sure that the behavior is working for the test runner rather than even just simply before your code. So this is something I would want to see all greens with. But I've got this extra thing that I coded into here. And basically you can see here I'm calling this number 2 version of it. And I'm passing 0. You can see here, created for test runner. Given 0, I expect 1. So here's, I'm passing 0, and I'm asserting that it's coming back. This is expected than actual, that the expected value coming back is 1. And of course, the actual I'll be getting back as this final count here. This is the one that's failing here. So I'm giving 10, and I'm expecting 10 because of that maximum thing, and I'm not getting it. So I have to go back and look in the code, and you can see here what I'm going to do is basically I'm just going to call the one that's actually working here without the 2. So go back to test runner and change this to be a 1, or I'm sorry, just to not have the 2 on there, and then save that and recompile. And there we go, and then we'll run all. and boom, all green. So everything is good. And it just is telling me that this test runner environment as it created in Unity is all configured properly and has all the references, has all the access to the files that it needs. So it's just a, a big Granimal kind of thing to make sure that everything is working in terms of the framework. Okay, so grand. Now let's get into the unit tests. So here, the next thing I did is I had a routine, and it was a really simple one. So I really didn't do that much. It basically, I created it just to kind of keep the code clean. I call this is the turn playable. I call it in a lot of different places. The logic is pretty easy, but I wanted to keep the code pretty. So I made it a method that I could call on and invoke later. And so basically what I'm doing is I'm just making sure that I'm in bounds. So with the number of turns, because I'm working with an array, and so the turns can't be less than 0 and it can't be equal to max turns in the programming. And then as long as I'm in bounds with this is turn playable, then the logic is pretty simple. If the turn has been plotted, in other words, we know the final location of where the planes shall be. And so this is the red A, the Baron von Red player. If that's been plotted, and right there, if Olive B, if Lord Olive has also plotted, well, then this turn is playable. And so then we return the true, if not false, and this is then just we return false if we're out of bounds with our turn. Okay, so it's a pretty simple application, but what I did is I messed it up. And so you can see I just kind of go back and forth here. I messed up the logic for the turn, so the boundary conditions. Then I also here messed up in terms of I'm ORing these two rather than ands, which is I wouldn't say a very common, but a relatively common kind of programming kind of bug or something. If this was more complex, obviously you were in here changing it, you may make the wrong have the wrong results with that. So let's take a look at the test case for that. So I have two test cases that are testing the boundary conditions. One is if I'm passing in a turn that's -1, and the other is if I'm passing in a turn that's at max turn. And in both cases, we're expecting a false result. We want the routine to gracefully handle that and jump out of there. The other logic conditions, basically we've got two booleans, so it's really 4 conditions. In this case, if the turn has been plotted is false for both players, then the result we expect is false. If it's false for just one of them, right, true for one but false for the other, we can't play that yet because we haven't plotted where B is located yet. And so in this case, then we expect that's going to be the false result. Just the opposite, right, where A has plotted as false and B is plotted as true, we still expect false. Then here's the sunny day logic, where both have been plotted, so we know where the end result of those planes are. So now we can play this turn, and then we have the expected return value of true. So we know this already failed, and what we can say here is, okay, we've recoded, we've changed all of our logic to be proper. We had the or there, now we've changed it to an and. So now here we're going to make that call to the right place. So I'm going to do find, and is turn playable? Yep. We're going to do a replace. Grand. Okay, replace all. We'll recompile. And we'll run. And there we go. So we got our is turn playable unit test all passing with all green. So grand, all our coding changes were working. So that went even more aggressive, and I've got this plot maneuver, and this routine really is at the core of what the game does. And so I did the same thing where, by the way, I get great advice from Professor Penny, which is, he said, oh, you're maybe putting too many things, too many classes, too many objects, too many, all the different things inside of your move lerp 1, which is kind of that big C# thing. And then, yeah, that was poor programming style. Really, what you want to be able to have those references separate in different compiled, separately compiled C# programs, applications, have the classes and the data associated with those classes. You can have the methods operating against that data. It's a lot easier to read, a lot easier to maintain. And here is the key part that I didn't know going into this and that I've learned. A lot easier to test because it's very difficult to test um, uh, basically these non-static methods inside of the mono behavior, because mono behavior is a class where it's kind of event driven, and it's hard to in this Unity test runner to be able to test these event driven kinds of things. So I had to take these methods, move them out and abstract them from the actual program. So I spent the time to not rewrite, but to wrap the plot maneuver code, which was hard coded inside of the big fat MoveLert1 into a separate class and then a method inside of there, so that I could, not only maintain it better in the future, but I could also, of course, now unit test. So the actual code itself for the plot maneuver, fairly simple. Well, fairly simple. It wasn't simple to write in the first place. Let me put it that way. But basically, similar to the other, where I'm kind of testing the boundary conditions to make sure that the turns is correct and that the condition is ready for plotting this maneuver, because I need to know to plot this maneuver. I need to know if the previous turn has been played and if the current turn has not been plotted. And because with the asynchronous plot and simultaneous play, uh, the program, this routine can be called at all sorts of different places. And basically, there are 3 different turns that are active at one time in the game, all depending upon the state of the other player and the state of the current player. But you have 3 different turns, and it's like you're reading a book with your fingers kind of stuck in 3 different chapters, and you have to kind of reference to say, can I do this? Can I do that? And it's all based upon where your fingers are. And as you move down the turns, and these fingers kind of move down. So I'm just doing that logic in terms of keeping track of what the current turn is, but I have to sometimes take a look at the past turn and future turns to see what I can do at that time. So, like I said, simple logic, but getting this all correct was not simple. Once we know that, yes, we're here because the previous turn has been played, so we know the end position of the airplanes, but the next turn has not been plotted, so we need to plot this turn. We do, because the start of this turn is basically equal to the end of the turn before us, so we save that information. We store for every turn for both planes, we store both the start position and the end position, so then we can do the movement, the transformations between the start and end, and actually play then that turn. So that's the goal, is to have for each turn both the start and end positions available for the engine to actually then play it. Okay, so here we are then it's a big switch, and we pass into these 2 character codes for the maneuvers. I've got other maneuvers plotted. I think I'm up to 22. And so in some cases, these codes are 8 characters long. But it's just kind of an encoding of the different transformations that the plane's going to do. And so this looks simple now in terms of the mathematics, because for a lot of these, I'm either just moving the plane forward 0, just keeps the plane here, no transformations. F1 moves it forward 1, F2 moves it forward 2, and the lefts and rights are just turning the plane on a hexagon by looking at the hexagon side. So if I turn to the left one, I'm going to turn the plane in space left 60 degrees. But I've got more complex maneuvers planned, like the barrel roll is actually move forward 1, turn to the right 1, move forward 1, turn to the left 1, and then move forward 1. And of course, then the mirror of that barrel rolling to the left. And so this will be a lot more complex mathematics as we get going here. And another beautiful reason for having unit tests, because if I mess up that complex logic, then I want to know about it right away, rather than during play testing, which is a waste of time. And of course, especially if the play tester is another human out there. Okay, so that's the basic things that are going on here for the right turn here. I'm basically turning, adding to the end angle of the previous of this turn, adding 60 degrees because I'm turning right on that 1 hex side. Right 120. Eilerman is a right 3 times, but basically it's a 180 degree turn to the right. And then for the moving forwards, I need to know for this object what is the forward angle, and then I multiply that by the distance that I want to go in that direction. And for F1, it's distance 1. Right now, this is 200 meters, and then this is 400 meters for distance 2. So that's the basic mathematics and the logic that goes on in this plot maneuver. And what I'm going to do is I'm going to accidentally make some mistakes to it. So let me just kind of line these up so we can see relatively quickly what's going on here. So this is the original one, the one that's working. And so you can see here, what I'm doing is I've messed this the results up down in the bottom, and because I want to get into this, because this is the part that I really want to test. So I'm willing to have for this exercise some of the tests not fail, because I do really want to get into here, because this is I do want to have some of the boundary conditions kind of tested, but this is the meat of what I really need tested. And so here we are. What I'm doing for each one of them, you can just kind of see I'm messing with adding, we're here, this should not be moving at all. I'm adding in a little teeny movement in one of the axes. And then other times I'm turning things where I'm going forward in distances where I should be just turning to the right one. I'm actually moving the plane forward the 200 meters in a certain direction. So I've messed with each one of these with different kind of logic here. And again, they look relatively, once you understand the logic, you would think that, hey, we shouldn't really make this kind of programming mistake, but mindful that I will be having much more complex maneuvers coming up. And so the opportunity for making mistakes and introducing additional mistakes is much greater. So that's what's happening. So let's take a look at the test case to actually make that happen, the test script. So at the beginning, I've got a set of variables that I'm using and initializing and instantiating to be able to use them throughout the course of this test. And then this setup is actually, this is run once. And what I'm doing is I'm this game object, because every game object in Unity automatically already has a transform component. So you already know where the XYZ location is, you already know the XYZ rotation is, and you already know the scale in all those. And so we're just saying, hey, this new test object, we're just putting it in the center of the world. So, and then we're going to measure then the difference between where the center is and then where we're going to see if the transformations from the the plot maneuver is still correct. All right, so we got our boundary conditions that we're testing, basically similar kind of things. This turn 0, that should return a false, because we're in the game. The turn 0 is actually how the airplanes actually get there. So turn 0 has been played, because the end result is where the planes actually start turn 0. Turn 1 is the first game of the turn, and that, of course, needs to be plotted. So if I'm asking to plot turn 0, should be that's a false condition. So it should be returning false. Of course, that 200 should be a false condition. And then we get into the logic conditions. So here, I've got a cloudy day scenario, which is if the previous turn has not been played, then we don't know where the end position of that plane is, and we can't possibly plot the next turn. And so we should be returning false in this situation. It doesn't matter what the maneuver code is. The next one is if we send in a bad maneuver code. And so of course we want to come up with false to say, hey, I can't plot that. And we want the routine, of course, to gracefully handle that. The partially sunny day is for any turn, if the previous turn is true, that it has been plotted, but if the current turn has already been plotted, then we want to return a true. It's already been plotted, we want to return a true. And like I said, because of our fingers are in 3 different places in terms of the programming, and we're kind of sliding down the turns as we go. There are situations where I make a call to this routine just to make sure that the turn has been plotted. And if it already has been plotted, it's very quick, comes right back up to say, yep, it's been plotted. I'm not going to recalculate anything, and boom, we get back to here. But we want to return a true so that the caller knows that everything is still good. And then this is the traditional sunny day kind of scenario where we've played the previous turn, but the current turn has not been plotted, and we expect that we got a true coming back. So that's the sunny day kind of logic. And then we do all the different transformation logic to make sure that the mathematics is correct. So I'm going to take you through one of these, and all the rest then are similar in structure. Of course, the math is different, but similar in structure. So I'm just assigning it just a good old fashioned turn two, which is a fine turn. I've already done the asserts or the test to see if, for the boundary condition. So I'm hopefully test two will be just as good as test 20 or turn 20. So then what I'm doing is just making sure that indeed the previous turn is played is true, this turn is plotted as false to make the plot maneuver do its business, and then I pass to it the maneuver, and you can see this, that's what changes as we go through here, the different maneuvers, and I go through and test all of them. So like I explained before, we take the current transformations of where this test object is, which is in 0, 0, 0 in the world, and we assign those into the end positions for the previous turn, so we know where we ended, and then we calculate the new start turn, the new angles. This is our calculation here inside the test routine, and the T angle and T position are just the temporary start positions of this turn. And then we do the similar kinds of mathematics and transformations over here. And then we call the plot maneuver and see what the result is going to be. And then we assert that result. And here's, you read, and you stumble across things that are just spectacular. And here's an assert that tests to see if two vector threes are actually equal. And of course, they'll maybe never be exactly equal. But here's a range. An error is assumed with this, very small error, but an error. And so it's a fine tool here to say that the actual here is, this is what is is returned from the plot maneuver, and then this is equal to the expected, and this is the thing that I calculated separately right here. So we test both of those, both the angle and then the position of the airplane, and that's how we do that for the F1, and we do that for F0, F1, and we do it for all the different maneuvers. And again, the mathematics is going to be a lot more trickier as we get into some more of the complex kinds of maneuvers that I'm going to be allowing for this biplane. So that's the logic. And so if we go, the test logic, and if we go here, we say, ooh, we've got all these bugs, and then we code and we fix those bugs. So let's go back to the test maneuver, and just because we're such good programmers, I'm going to copy this, and we're going to say find that, and we're going to replace it to this. That's kind of nice that it did that, and we're going to replace all, because we're just such a good programmer. We did that very quickly. Recompile. Did I recompile? Yeah, there it is. Had to think about it for a bit, and then we'll clear results and then run. And wow, there we go. Because we're such a good programmer, we're able to fix all those bugs just with a few keystrokes. And so that is the testing in Unity, unit testing in Unity. Next thing I really do want to play with is the Unity has, this is testing for kind of static things, and for unit testing, the next thing I want to do is to start playing with the doing more of the integration test, where right now the game is button driven events, and so I want to be able to have the automate in play mode pressing of these buttons and trying them in different paths, because honestly I do spend a lot of time as I'm changing my state machine and my game logic. I go play the game and I kind of make sure that I go from when I press this button I go to that state, and the banners and displays are correct. So that's my next goal with this. But this is this is very useful kind of thing, and I learned from this, right, the kind of the encapsulation in terms of object-oriented programming is very powerful, is very useful. It's easy to kind of throw everything together, but the more you can encapsulate, the more you can separate the data and and the logic from the rest of the workings inside the model behavior, the better it is for your readability, for maintainability, and then for testing. Performance, may have an effect, but the game that I'm writing right now is not going to be a performance beast. It's not like I need 60 frames per second kind of thing. So I think I can afford that to really try to learn and grow and do better with my programming over time. So anyway, a very interesting exercise. Thank you very much. I'm going to stop my sharing and send you back onto your day. So again, have a good day. If you have any questions or comments, please let me know.